Good morning, students. Today, let us learn the basics of dynamic memory allocation. Before doing the structures-based programs in the today's lab session. Why we need dynamic memory allocation? What is the issue to replace it with dynamic memory allocation? So the issue arises from the concept known as arrays. Okay, when we use arrays, a fixed size of memory is allocated. Sometimes we may be using only less amount of memory which was allocated earlier by the arrays. Sometimes otherwise sometimes we will be using more, we may require more number of more memory space than the allocated. Otherwise we won't use the memory at all. Okay, so these are the few issues we face with the fixed size arrays. Okay, to replace those, to resolve those issues, we go for dynamic memory allocation. Dynamic memory allocation is a concept which solves the problem of allocating memory at the static time, that is during compile time itself. Allocation happens in case of array based programs. Okay, so that sort of problems are overcome by this dynamic memory allocation concept. So in this case, what happens is memory is allocated during the runtime. Okay, so how it is possible? So four functions are there in C library which are helpful to manage the memory in during the runtime. Dynamic in the sense runtime. Okay, after compilation, so whatever memory is needed by the program will be allocated and deallocated during its runtime. That is what is the meaning of the word dynamic memory allocation. The four functions available in the C library are malloc, that is memory allocation of, and calloc, that is called as contiguous allocation, and the third is realloc. Third is the realloc function, and the fourth is free of function. Okay, so malloc stands for memory allocation, which is used to allocate the memory with the specified size and to store the specific set of specific type of information in that allocated memory. And in case of calloc, okay, so it stands for a contiguous allocation. It is used to allocate memory in the memory continuously. Okay, so physically it will be allocated continuously in the memory. Okay, realloc. Okay, if we want to erase whatever allocated, erase the memory, or if we don't want to use the memory which was already allocated, and if we want to use it for further programming concept, or for storing some other data, so we can realloc. We can make use of this realloc function and erase whatever allocated earlier, and we can make a new allocation with the help of realloc function. And the final function is free function, which is used to deallocate all the memory which were allocated earlier. Okay, and whenever we call these functions will return a pointer. Okay, so these functions allocate memory and return the address of the first address of the allocated memory. Okay, that is nothing but a pointer value that should be stored in a pointer variable. Okay, so with the help of that pointer variable, we can access those allocated memory further. Okay, so let us see each of these functions. The first function for our discussion is malloc. Okay, so as we said earlier, so malloc stands for memory allocation. The syntax of this memory allocation malloc function is the data type of the memory cost type. Okay, and this malloc function is going to return a address. Okay, so and its type is a pointer variable. Okay, and malloc function name and the size of the memory to be allocated. For example, malloc of float star malloc of 100 into size of float. Okay, so here this allocation allocates this malloc function allocates 100 memory places to store the float numbers. Okay, so why the size of function used here is, so each data type will have its own size. Okay, for example, integers will occupy 8 bytes of memory. Okay, and float will have different, double will have different size, and character will have different size. Okay, so in order to identify the amount of number of bytes that will be occupied by each data type, size of function is used. Okay, then this memory should be used to store the float type, and hence it has been casted to float, and whatever address returned by this malloc function is stored in the PTR variable called as point variable called as PTR. Okay, so that's all about the malloc function. The next function comes the calloc function. Calloc stands for contiguous allocation, and this function differs from malloc in a very in the way in which it allocates memory. Okay, malloc function will allocate memory by collecting memory spaces here and there, whereas calloc function will allocate memory continuously. Okay, so you will have a sequence of addresses allocated. Okay, so that's what is the only difference, and there is a slight variation in the syntax as well. Okay, so we need to, similar to malloc, we need to provide the cast type, the name of the function calloc, and the size of the data type, and the amount of memory to be allocated. Okay, so here is an example: float, calloc, and 25 memory locations to be allocated for storing float variables. Okay, so this function also returns the address of the initial address of the allocated memory. That address is collected in the point variable known as PTR. Okay, another example is given here for malloc. You can imagine. Okay, malloc of 5 star size of int means, so how many int occupies how many bytes? 4 bytes of memory. Okay, so it is compiler dependent. In modern compilers integers occupy 8 bytes of memory. Okay, so in regular compilers integer occupies only 4 bytes of memory. So and in order to store 5 integer numbers, we need 5 into 4 bytes, that is 20 bytes of memory is allocated during the runtime by the malloc function. Okay, and the initial address, the first allocated memory cell's address is stored in the variable PTR. Okay, since it's going to be an integer point, it's going to store the integer values address. This point variable should be of integer type. Okay, yeah, so this is calloc example. Okay, so this is also allocating memory for storing 5 integers, but in continuous locations. Okay, 5 blocks of 4 bytes each is dynamically allocated to PTR. Okay, and the next function is realloc. Realloc stands for reallocation of the memory. Okay, whatever memory allocated by malloc and calloc can be reallocated. Okay, we can reclaim the allocated memory and reallocate for the newer one. Okay, that's what is the logic of this logic behind this realloc function. So it requires already existing pointer, and here is its syntax. Okay, so realloc of and already existing address, starting address, and the size of the new allocation. Okay, so already we have allocated allocated memory for storing 5 integer variables, and its address is in the variable known as PTR. Okay, so by making use of this PTR here, we are going to reallocate, okay, from the initial address that is stored in the pointer variable PTR. We are going to reallocate, okay, in addition to the memory 5 memory locations of integers already allocated, we are going to allocate 5 more extra memory location in order to store 10 integer variables. Okay, here it has allocated only 5, but here it is reallocating memory for storing 10 integer variable numbers. Okay, so this is what happens when we reallocate. Okay, the last dynamic memory allocation function is free function. Okay, so it is an important thing in programming is that, so whatever we allocate, that should be reclaimed. Okay, so whatever, if we reserve the resources after using it, we have to release them. That is the one fine tip while we must follow while programming. So here also in dynamic programming, we have a function known as free of function, which is used to reclaim the allocated memory, that is release the allocated memory. Okay, all it needs is to provide the pointer. Okay, so here, for example, here we allocate memory using calloc function. Okay, so its address is stored in the variable PTR. After the allocation, we may be using this memory allocator for storing the data, for receiving, for processing, whatever may be the operation. Okay, after using these memory locations, we need to free them. Okay, so that only, so it will be made available when we execute another program. Okay, so otherwise we may run out of the program, run out of the memory. Okay, so sometimes we may face the insufficient memory locations like that. Okay, so we have to do some cleanup work at the end of the program. Okay, so this is what this function is doing, the cleanup job. Okay, so it's going to if we supply this pointer variable to the function free of, so it will simply remove the data and as well as the address stored in this pointer variable. Okay, hope you guys understood this concept. So now let us implement structures and union concept based on this dynamic memory allocation concepts. Thank you.